if it is not possible to get a common base with these exponential equations, then what we're going to do is, number one, we're going to isolate, means get it by itself, the exponential expression. Okay, so like with number one, that exponential, the 5 to the power, is isolated. It's by itself. It doesn't have anything in front of it, behind it. The only thing it's got is its exponent. And then we're going to, this paper says take the log of both sides. I wrote on your paper beside that, write in log form. I like that better than taking the log of both sides. And that's the purpose of us learning logarithms. And then we may need to simplify and then solve and check for what we call extraneous solutions. We talked about this a little bit, the extraneous solutions. That means you get the answer, but when you plug it back in, it doesn't work out. Okay, so let's look at an example of this. Okay, so number 3. 2 to the x is equal to 61. 2 to the x is equal to 61. 61 is not a power of 2. It's impossible to get a common base on both sides of this equation right here. So step 1, we isolate the exponential. Well, it's already isolated, okay? So after we get it by itself, we write it in log form. So remember what log form looks like. The base of the exponential is the base of the logarithm. So it's log base 2. Y'all can't see what I'm doing. Log base 2. Okay. And then the other two parts switch places. So the 61 goes inside the logarithm. The x goes to the other side of the equation. So this is the exact answer right here. Okay. This is the exact answer. Log base 2 of 61 is the exact answer. They may ask you for a decimal approximation. And if so, we use our change of base. Remember, that's log of 61 divided by the log of 2 will give us an approximate answer for this x. So let's do that. Let's do log of 61 divided by the log of 2. So our approximate answer is about 5.931. It's an equation. Plug it back in to check it. So 2 to the, let's use the rounded answer so I can show you how it doesn't give you exactly 61, but it's very, very close to 61. If you had done this instead after you typed in that logarithm right there, if you had done 2 raised to the answer, second negative, okay, it would give you exactly 61 because it wasn't putting in a rounded answer. Okay, but I just wanted to point out a few things. So that's the exact, this is the approximate. It just depends on what the answer choices look like. They may be in log form, they may be in decimal form. You just got to figure it out from there. But these are the same thing right here. Log base 2 of 61 and 5.931, same answer. Okay, number 4, 8 and 92. Can't write those with the same base. Okay, they have nothing in common with each other. 8 we could write as a base of 2, but we can't write 92 as a base of 2. So let's go to isolating it. Well, it's by itself. Okay, there's nothing being added or subtracted to it or multiplied by it. So it's already by itself, so we can write it in log form. The base of the exponential is always the base of the logarithm. The 92 goes inside the log. The m minus 7 goes to the other side. But we haven't completely solved for the variable yet. Right now it's m minus 7. So we need to add 7, but here's the deal. You never change what's inside your logarithm. Okay, that plus 7 just gets tacked on to the end. You never change what's inside that logarithm. Once you write that number in there, it doesn't change. You can't add and subtract things to it. So that's the exact answer. The approximate answer would be done by finding log 92 divided by the log of 8 and adding 7. log 92. Make sure you close your parentheses. Divided by the log of 8 plus 7. So our approximate answer is 9.175. Again, we can check it. 8 raised to the parentheses. I'm going to do second answer. Minus 7.
This is just a reminder for all first period teachers to send your juniors to the media center during your ACT time. Thank you.
Okay, so if 8 o'clock was your time, y'all can go ahead and go. Please hustle back when it's done. You're only supposed to be up there for 15 minutes. Yes, there are different times. Yes, ma'am. Okay. Let's see here. You are probably in. Nathan, what was your time? 8:15. I think you're in that group. Okay, so I checked the answer. I got 92. Okay, so we're good. So this isn't too bad, right? All right, number 5. We've got 4 times 7 to the n is equal to 148. So we've got to get the exponential by itself. Right now it's being multiplied by 4, so how do we get it by itself? Anybody? Divide both sides by 4, right? It was being multiplied by 4, then we divide both sides by 4. Hopefully 148 is evenly divisible by 4. Guess this. We get 37. Okay? Now, we would love it if 7 were a power of, if 37 were a power of 7. It is not. So we've got to write it in log form. Log base 7 of 37 equals n. We don't have to do any more work past that point. Okay? That is the exact answer for n. If we wanted an approximate answer, we use our change of base. Again, I'm writing it over and over and over again in hopes that the more you write it, the more you will remember this is how I can do this in my calculator. Because I promise you, I can almost promise you that you will see a problem, at least one problem like this on the exam. And change of base is so easy to do if you remember what to type in. 4 times 7 to the 1.855 does give us 148. Okay, number 6. 4 to the 3w minus 5 is equal to 3. We've got to move that minus 5 first. We've got to isolate the exponential. So we add 5 to both sides. We get 4 to the 3w is equal to 8. Can we write this one so that they have the same base on both sides? We sure can. 4 and 8 are both powers of 2. But here's the good news. If you're not looking for that, the other way that we've been doing it will still work. It's just more work than you need to do. So 4 is 2 squared. 8 is 2 cubed. So we've got 2 times 3w, which is 6w, is equal to 3. So we divide both sides by 6. So w equals 1/2. So be on the lookout for stuff like that. Okay, let's check it just to make sure. 4 raised to the parentheses, 3 times 0.5, close your parentheses, minus 5 equals 3. Okay, so again, the other way will work too. I promise you, the other way will work as well, but it's just a little bit more work than you have to do if you recognize that you could write those with the same base. Okay, let's do the examples on the back side. These are going pretty quick, and then I will stop talking for a while. Okay, number 7, we've got 7 minus 4 to the x plus 1 is equal to 18. We've got to get this exponential expression by itself. So it'll probably help a lot of you to circle that exponential expression so that you can see what all's going on around it. So first of all, we need to subtract 7 from both sides. And I'm going to keep circling it. because we also have to get rid of that negative. Okay, we also have to get rid of that negative. So how do we get rid of that negative? Divide by -1, right? So 4 to the x plus 1 is equal to -11. Write it in log form. Log base 4 of -11 is equal to x plus 1. And then subtract 1 from both sides. So log base 4 of -11 minus 1 is equal to x. Remember, we can't change that number. Now let's type that into our calculators and see what we get. Log of -11 divided by the log of 4 minus 1. I got an error message. It says non-real answer. Let's think about this a little bit. Let's go back a few steps. Let's go back to where we've got 4 to the x plus 1 is equal to -11. So we are raising 4 to a power, and it's saying the answer is -11. Can we raise positive 4 to a power and get a negative number? No, it's a positive number. Anytime you raise a positive number to a power, the result is always going to be a positive number. It is impossible for 4, or any number for that matter, any positive number, to be raised to a power and get a negative number. So really, this work that we did right here, yes, mathematically, that's what we would do, but it's not even applicable because this is not possible. Okay, that is not possible. So this is no solution. Okay, no solution. So I did that on purpose. Okay, I knew that it was supposed to be no solution, but I wanted to show you what you would end up getting in your calculator if that was the case. Okay, number 8. We've got to get that exponential expression 5 to the 3k minus 3 by itself. So we need to start by dividing by 10. So we get 5 to the 3k minus 3 is equal to 4. Unfortunately, 5 and 4, we cannot write them so that they have the same base. So let's put it in log form. Log base 5 of 4 is equal to 3k minus 3. So then we add 3. Log base 5 of 4 plus 3 is equal to 3k. And then we divide the entire thing by 3. So here is our exact answer. So let me show you how to get the approximate answer. You got to be careful when you type this one in. Okay, log of 4, close the parentheses, divided by the log of 5, close the parentheses, plus 3. I'm going to go ahead and press enter because I have to divide the entire thing by 3. So this is the easiest way to do that. It's to put the top part in, press enter, and then divide by the 3 that was in the denominator. So this is approximately 1.287. No reason not to check our answer. 10 times 5 raised to the parentheses, 3 times the answer, minus 3. It gives us 40. Okay? It gives us 40. So always take a second to check your answers. Or I'm also showing this because you can plug in your answer choices. If you forget what to do, plug in the answer choices. Okay, number 9. We've got to get 3 to the n by itself. What do we need to move first? 15. We got to subtract 15 from both sides. 4 times 3 to the n equals, when we subtract 15, we get what? 344. Divide both sides by 4. 3 to the n equals 344 divided by 4. It's Friday. My mental math's not working quite well. 86. Okay. 3 and 86. We cannot write 86 so that it has base 3, so we got to go to log form. Log base 3 of 86 equals n. That's our exact answer. Let's get an approximate answer. Log of 86 divided by the log of 3. Approximately 4.055. Check it. 4 times 3 raised to the answer plus 15. Notice I didn't use any parentheses that time because there was only the variable in the exponent. I don't need any parentheses. The 15 is not in the exponent. Okay, number 10. Negative 2 times 5 to the p plus 7 equals negative 63. What do we need to do first? Anybody? Subtract 7. Negative 2 times 5 to the p equals negative 70. Then we divide by negative 2. 5 to the p equals 35. 5 times 7 is 35, but that doesn't do us any good exponentially. So we put it in log form. Log base 5 of 35 equals p. That's our exact answer. Let's get our approximate answer. Log 35 divided by the log of 5. Approximately 2.209. Check it. Negative 2 times 5 raised to the answer plus 7. Negative 63. Okay, let's knock out those last few really quick. Or actually, y'all do this. Okay, y'all.